Hey everyone, this is Luke from Catus Maths, and today's video will be about the complex numbers, in particular adding and multiplying complex numbers. Complex numbers are often used in physics. Complex numbers are defined as the set of numbers a plus bi, where a and b are real numbers. A complex number z is sometimes written as x plus I, y. In our videos, though, we will keep to denoting a complex number z as a plus bi, where we call a the real part of the complex number and b the imaginary part of the complex number. And I has a very special property. I is a number defined as the square root of -1, and together this is a complex number. Let's say z1 is equal to a plus bi. As before, a is the real part, b is the imaginary part of the complex number, and z2 is equal to c plus di, where c is the real part, and d is the imaginary part of this complex number. When we add them, we have a plus bi plus c plus di. And to add two complex numbers, we add the real parts together and the imaginary parts together. Let's have a go at adding two complex numbers, where one of them is 2 plus 3i and the other is 5 plus 2i. So we're going to add the real parts together, 2 plus 5, and the imaginary parts together, 3 plus 2. And so the new complex number is 7 plus 5i. Complex numbers can be represented geometrically too, with an imaginary axis and a real axis. The imaginary axis just represent the multiples of I. We can represent the complex number 2 plus 3i like a vector. And let's say we want to add this complex number to another one, 5 plus 2i. Geometrically, we can use the parallelogram rule, where we form a parallelogram with these complex numbers represented as vectors. And we know that the fourth vertex, or the fourth corner of this parallelogram, is equal to the sum of the two complex numbers, which is equal to 7 plus 5i. So adding complex numbers is really adding the real components with the imaginary components. Let's revisit our two complex numbers, z1 and z2, which are made up of real and imaginary parts. How would we multiply two complex numbers, z1 and z2? Let's now write out our two complex numbers and separate them with brackets. Well, just like how we use arithmetic with our real numbers, we're going to use our FOIL method to expand these brackets. FOIL meaning first, outer, inner, and last. So just like how we would with real numbers, we're going to multiply entry by entry. However, we have to keep in mind that I squared is equal to -1. So once we have expanded our brackets by multiplying entry by entry, we have this. Now I squared is equal to -1, so the plus becomes a minus. Finally, we can factorize to make it look neater, and so it looks like this. Let's do an example together, with z1 and z2 being two complex numbers, 1 plus 3i and 3 plus 2i respectively. To multiply, we write out our complex numbers with brackets. We're going to multiply entry by entry, so 1 times 3 plus 1 times 2i, and 3i times 3 plus 3i times 2i. And remember, I squared, or I times I, is equal to -1. So once we've expanded the brackets, we have to keep an eye. 3i times 2i equals -6. So we have 3 plus 11i minus 6, which is equal to -3 plus 11i. Interestingly, when we multiply two complex numbers, geometrically speaking, something very interesting happens. When we have our two complex numbers, let's say z1, represented by our green arrow, and Z2, another complex number, represented by the orange arrow. When we multiply these two complex numbers together, what we're doing is we're adding the angles and then multiplying the magnitudes in the same direction. This is represented by the blue arrow. Thanks so much for watching. I hope you enjoyed it, and I'll see you in the next one.